Two students are talking, and one said, I used to think that correlation implied causation. Then I took a statistics class. Now I don't. Sounds like the class helped. Well, maybe. And what makes that so funny is he doesn't know if the statistics class was simply correlated or caused the improved state. Anyway, so let's go ahead and talk about observation and experiment, which has something to do with correlation and relationships and causation. So let's look at this. There's television's value to kids. It's all in how they use it. So they found that children under 3 years old who watched more than 2 hours of television per day tended to score lower on measures of reading achievement and short-term memory. The researchers had no control on how much TV was watched. So the way the children is an important aspect. Who is doing the choosing on the television? It is the subjects. I don't know if the parents have some control on it, but it's definitely not the researchers saying you need to watch this many hours of TV. When the subjects are the ones doing the choosing of the level of the treatment, then this is called an observational study. So, what is an observational study? We look at what's chosen. It's kind of in the wild. And there are two types. One is retrospective, where we go back and look up the data and try to come to some conclusions. And the other is prospective. We can actually just do an observational study with the subjects in the wild, don't change anything about them, and let them pick what they're going to pick. This can be used to discover trends and possible relationships, but it is not possible to demonstrate a causal relationship with an observational study. So back in the 90s, they wanted to know, does taking hormones, hormone replacement therapy, reduce heart attack risk after menopause? So in 1992, several medical organizations actually said, yes, you should take hormone replacement therapy. It will reduce your risk of heart attack by 35 to 50%. And this was based on observational studies that compared women who took hormones and those who didn't. And they found out that women who were taking hormones did have 35 to 50% lower risk of heart attack. But let's take a look at the women who took hormones. Women who did take hormones were also richer, better educated, and saw their doctors more frequently than the group who didn't. So what we want to talk about now is confounding. Confounding occurs when two variables, and you can have more, are associated in such a way that their effects on a response variable cannot be distinguished from each other. So what are the possible confounding variables in this study? Well, the women were richer. Maybe they could afford better health care. They were better educated. Better educated tends to mean better health care. By the way, it also tends to mean richer. And since they were richer, they could definitely afford to see their doctors more frequently, and that could be due to their education. So all of those could be mixed in. All right, I want to give you a quick textbook alert. So you're going to see the words lurking and lurking variables in your text right about when we're talking about observational studies. Well, these terms are no longer used on the AP test, which actually makes your life easier because your book has both the word lurking and confounding, and you were supposed to kind of tell them apart. Good news, just use confounding and confounding variables. I can find it quite confounding, telling the difference between a lurking and a confounding variable. That's probably why the AP test said we're just calling them confounding. All right, so what was the problem with this? This was based on an observational study. So what if we really want to know, does hormone replacement therapy actually really reduce heart attack risk? Well, we could do an experiment. So we're going to get rid of the confounding variables. So how do we do that? We don't let the women decide. We randomly assign them to hormone replacement pills or a placebo. And if we randomize, that's very important, then we can control for the confounding variables. So by 2002, they had several experiments and agreed, guess what? Hormone replacement therapy did not reduce the risk of heart attacks. It had something to do with those other variables. So it was related to heart attack risk, but that did not cause the change in heart attack risk. Something else was causing it. So again, the earlier study was confused by confounding variables. So let me give you some basics on experiments and what are important about them. We use them to investigate possible causal relationships. We like to know when something causes something else. So in the last example, did hormone replacement therapy actually affect the heart attack risk? We need a factor, an explanatory variable. So in this case, we were looking at hormone replacement therapy. Did that affect the heart attack risk? Then we're going to apply different levels of the factor to create treatments. In the last case, they did hormone replacement and then they did placebo. So both subjects thought they were getting the same treatment, or they thought they were getting some treatment, and they couldn't really tell the difference. And you have to make sure that each subject is given a treatment. Even when you're doing placebos, there's a reason for placebos. We'll talk about it later. You want the subject receiving something. All right. Now, once you've done that, you measure the response variable to see if the differences in treatment explains the differences in response. And then one important caveat on experiments, it really requires random assignment of subjects to treatments. Do not let the subjects choose. And even the researcher, you have to be a little bit careful about them choosing. All right. So we're going to do some practice now, just looking at the difference between examples, observational study or experiment. So if you can tell which is which. Smartphone Nation in the AARP Bulletin. If you love your smartphone, you are not alone. Half of all boomers, people a little bit older than me actually, sleep with their cell phone within arm's length. 2 of 3 people ages 50 to 64 use a cell phone to take photos, according to a Pew Research Center report. So is this an observational study or an experiment? Well, first of all, I think we're talking about, people using the cell phones. Who's choosing whether these people use the cell phones? Well, the subjects are choosing whether they use the cell phones. Researchers didn't say, oh, you have to take a picture. They were assigning it to the subjects. So this is actually an observational study. Next one, How Children Learn in USA Today, October 19th in 2010. So study participants included 64 18-month-old toddlers. And they played in a lab. They had toys. There was a robot hidden, so you couldn't see it when you first came in. And after they allowed the kids to play around and they got kind of comfortable, then they took the screen away. And the kids could see the robot. But these are little 18-month-old kids, so they're not quite sure if it's a toy or not. So in some tests, the grown-up would talk to the robot and play with it and then leave the room. In others, the adult would just completely ignore the robot. So after the grown-up left the room, the robot then beeped, turned its head to look at a toy at the side of the infant. So when the grown-up played with the robot, the infant was 4 times more likely to follow the robot's gaze to the toy. So the little baby was looking. All right. So who's doing the choosing here, whether the toddler sees the adult play with the robot or not? It's the researchers are doing the choosing. If the researchers are doing the choosing, hopefully with random assignment, then it's an experiment. Next example, meditation and pain. A study was conducted to determine if meditation has an effect on sensitivity to pain. Subjects were assigned to one of 3 groups. They could A, meditate for 20 minutes. They could Group B, perform a distraction task for 20 minutes. And Group C, practice a relaxation technique for 20 minutes. And then they measured the sensitivity before and after the session, and they looked at those results. So is this an observational study or an experiment? Well, who's choosing the treatment? Well, the researchers are choosing the treatment. So this is an experiment. Next example, we've got Stanford University did a social isolation study. And here's what they did. They surveyed 4,113 adult Americans, and they concluded that internet use leads to increased social isolation. Okay, who's doing the choosing here? Well, in this case, it's the adult Americans, right? So they've already done it. It's an observational study. All right. The subjects are choosing to use the internet or not. Okay. Tots TV watching may spur attention problems. So they did, oh man, we're really worried about TV in these kiddos, aren't we? 2,500 children participated in a long-term health study. They looked at the records of these children. So they had already been participating in this health study. They looked at the records of these kiddos and found that 10% had attention disorders at age 7. They also found that the number of hours of TV watching was associated with an increased risk of having the attention disorder by age 7. So who's doing the choosing here? In this case, they did not say you're going to watch this much television or not. They're looking at records. So it's definitely an observational study.